Okay, there are three common methods for graphing a line. So let's take let's just take a standard line and we'll go through the three different methods. All right, so the first one is plotting points. In general, for graphing, this is the least desirable one, but if you're ever stuck, you can use it. So this is where you set up a table of x and y values, and then you plot those values. So we could do like -2, 0, +2, plug those in and figure out what our points are. Okay, so if we plug -2 into here, let me work it out down here. So if we plug in -2, we're going to get -4 minus y equals 8. We're going to add 4, and we get -y equals 12. Multiply through by negative, we get y is -12. Okay, then we plug in 0 into the equation, so we get 2 times 0 minus y equals 8. 2 times 0 is just 0. We've got -y equals 8, so I need to multiply everything through again by a negative. So we get +y and -8. And then we're going to plug in 2. So 2 times 2 minus y equals 8, so that's going to be 4 minus y equals 8. Subtract 4 from each side. We get -y equals 4. Again, multiply through by a negative, and we get y is -4. Okay, so let me redraw this just a little bit bigger. All right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 2, 3, 6, 2, 3, 4, 5, 6. Okay, so we've got -2, -12. That's going to be here. Then we've got 0, -8. That should be here. And then we've got 2, -4, and that should be about here. Here. 6, 8, 10, 12. Okay, so there's our 3 points, and we can see that they're in a line. Now, if we wanted to have a better line, we might need to go out to like maybe 3 or 4 and try to get a little bit more of this line. But we do have a line. Okay, that's kind of the downside of plotting points, is you don't really know where you're going to be, or how big your like how far down or up you're going to be, and so it can be a little bit hard to get your whole graph in, but from the points that you pick. All right, but we got a line. All right, the second method is to use intercepts. Okay, so remember, for the x-intercept, we plug in y equals 0, and for the y-intercept, we plug in x equals 0. Okay, so that's always true for intercepts. So using the same equation for this one, we would, so let's find the y-intercept. So we put in 0 for x. We've actually already done this. 2 times 0 minus y equals 8. That's going to be 0. -y equals 8. Multiply through by a negative. And we're going to get +y equals -8. So there's our y-intercept. We do the x-intercept by putting in 0 for y. And we solve for x. So that's just 2x equals 8. Divide by 2. And we get that x equals 4. Okay, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. Okay, so we get the same line. The nice thing about this one is we know exactly where it hits the two axes. So this one we only had over here. We kind of had to keep going and hope that it hit. And we were actually off by a little bit there. This one might be a little bit more accurate. The tough thing here is you might end up with fractions for the intercepts. That's pretty typical, and that's okay. So that might, you might get fractions with this one as well. Okay, so we've got plotting points, we've got intercepts. So now let's go on to the third method. We're going to use the same line, but we're going to talk about the third method for a second. Okay, so the third method starts with the slope formula. And okay, let me just put this here. We're going to use y equals mx plus b, okay? So this method starts with the slope formula, which we defined in the last video, y2 minus y1 over x2 minus x1. And we're going to use it for a generic point xy. Okay, so those are going to stay variables. And our y-intercept, whoops, I did that backwards, 0b. Okay, so remember that anytime you have a point in this form, it's automatically the y-intercept. X is 0, so we don't go left to right, we only go up or down, and b is the y-intercept. All right, so that's what we talked about just a second ago with the intercepts. Plug in 0 for x, and you get the y-intercept. Okay, so we're going to plug in xy 0b. So our slope formula becomes y minus b. Okay, so this is like my x2, y2, and this is like my x1, y1. Okay, so y minus b over x minus 0. Okay, so I get this. X minus 0 is just x. So my equation is now the same as this. And remember, you clear a fraction by multiplying by the denominator. So xm or mx equals y minus b. And now I can get y by itself if I add b to the other side. And I get mx plus b equals y. Or in other words, usually we write it as y equals mx plus b. Okay, so this is just kind of a special form of the slope equation. We know that m is the slope because we defined it and set it up that way. And we know that b has to be the y-intercept. Okay, so that's the way that we set it up, was using the slope and using the y-intercept. So we rearranged it and it looks like this, but this is always going to be the case. The slope will be in front of the x and the y-intercept will be the constant by itself when it's in this form. Okay, so we can use that to graph because if we can get our equation in this form, we know the slope and the y-intercept. So let's see, our equation was 2x minus y equals 8. Okay, so to get it in slope-intercept form, we need to solve for y. So we're going to move all this stuff to the other side. So we're going to do minus 2x minus 2x. Now we can write this as 8 minus 2x or negative 2x plus 8. Either way is perfectly fine. Okay, and then to get y by itself, we need to multiply through by a negative 1. We're going to change all the signs. So we get y equals 2x minus 8. Okay, so we rearranged the equation that we were given to be in slope-intercept form. So that means this number is the slope, and this number is the y-intercept. Make sure that you take the sign with it. So when we go to graph this, okay, the slope tells us where to go. So the slope is 2. That's the same as 2 over 1. That tells us to go up 2 and right 1. And the y-intercept is negative 8. That tells us where to start. So the y-intercept tells us where to start, and the slope tells us where to go from there. So we're going to start at negative 8. I'm going to do this in blue so you can see it. 2, 4, 6, 8. We're going to start at negative 8, and then the slope tells us to go up 2 over 1, up 2 over 1, up 2 over 1. We can do this as many times as we want, up 2 over 1, and that's going to hit the x-axis right there. Okay, so you really only have to do it one time, but you can do it more if you want a better picture. Okay, and there's our line. And if you look back at the last ones that we did, it's the exact same line. Okay, so that gives you 3 methods to graph. Let's recap. Get rid of all this. Okay, so 3 methods to graph lines. One is plotting points. Okay, that's where you plug in different x's and y's, or plug in different x's and get the y's that go with them. The second is to use intercepts. Okay, so that's where you plug in 0 for x and 0 for y. And the third is to get it in slope-intercept form. This is called slope-intercept form because you can see the slope and the intercept. So you get y by itself, and you can use the slope and the intercept to graph it. Okay, so we know how to graph a standard type of line. There are two other lines that we need to look at, and that's vertical and horizontal. Oops, horizontal. Okay, so vertical and horizontal lines, the equation looks a little bit differently. It's not going to look like slope-intercept form or that you can get it into slope-intercept form. So let's look at something that looks like x equals a number. Okay, so let's start with x equals 5. Okay, so what that means is that x is always 5, and y can be anything, because y is not even part of the equation. So y can be anything, x is always 5. So you get points like 5, 0, 5, -3, 5, 4. Okay, x is always 5, y can be anything. So 1, 2, 3, 4, 5. Okay, so we get 5, 0. It crosses at x equals 5. That makes sense. 5, 4 could be there. 5, -3 would be there. We could make all sorts of points along here, and they would all make up this vertical line that looks like this. Okay, so x equals 5 is a vertical line at 5. If we wanted to do, let me take this out. Okay, if we want to do x equals -2, that's going to be a vertical line passing through x equals -2. So that's right here. So we're going to have a vertical line here at -2. Okay, so it has to cross at that x value, but it also has all the points with that x value as well. Okay, so similarly, let's say we have y equals 4. Okay, that means y is always 4. X can be anything, so we get points like 0, 4, 2, 4, -3, 4. Okay, x can be anything, y is always 4. Whoops. Okay, so 0, 4 would be right there. 2, 4 would be right there. -3, 4 is right there. And we could go on. Any point with 4 in the y value would be it. And that's going to give us a horizontal line. Okay, so x equals a number is a vertical line, y equals a number is a horizontal line. Okay, so if we wanted to do, let's say we want to do y equals -3, that would be a horizontal line passing through -3. And we can go ahead and fill that in. Okay, now if you remember from our slope discussion, the slope here is undefined. Okay, because change in y over change in x. Okay, what the change in y can be anything. There is no change in x, so we're going to have some number over 0. That's going to be undefined. And then over here, remember that the slope is always 0, because the change in y is 0, and then the change in x can be anything. So 0 over anything is 0. All right, so the slope is undefined, so obviously we can't get that into slope-intercept form. And this one, the slope is 0, so the y equals mx plus b part, the m is 0, so that part just disappears. So all you have is y equals b. So that's just equal to a number. Okay, so vertical and horizontal are kind of special cases, but this is what they look like. You can remember that, or you can figure it out by thinking of a few points, and you can get the line that way.